Look around you. Every memory, every story, every moment in human history has unfolded on this tiny blue, our Earth. But how big is the universe beyond our home? How far does space extend? Tonight, we embark on a journey from the familiar to the unimaginable. We begin our journey with our closest cosmic neighbor, the Moon, a mere 384,000 kilometers away. That's about the same as driving around the Earth 10 times. It has been our companion for billions of years, shaping tides and inspiring myths. But in the grand scale of space, it's just the first step outward. Beyond the Moon, the Sun dominates our solar system. A fiery giant, 109 times wider than Earth. It provides the energy that sustains life. But even at the speed of light, it takes 8 minutes for its rays to reach us. That's just the beginning of our voyage. Mars, the red planet, has long captured our imagination. With its towering volcanoes and vast canyons, it's a world both alien and familiar. Could it have once hosted life? Scientists continue the search. As we push past Mars, the solar system expands into realms few have seen. Jupiter, the gas giant, looms large, a swirling mass of storms and mystery. Its great red spot has raged for centuries. Saturn, adorned with its breathtaking rings, follows. But these planets, magnificent as they are mere stepping stones in our journey through the cosmos. As we venture beyond Neptune, we reach the Kuiper Belt, a distant region filled with icy remnants from the solar system's formation. Here lies Pluto, once considered our 9th planet, now a dwarf among giants. And beyond Pluto, the Oort cloud, a vast, icy shell surrounding our solar system, where comets are born. At the very edge, Voyager 1 drifts through interstellar space, the farthest human-made object from Earth. It carries a message, a golden record of Earth's sounds, greetings, and music, drifting endlessly among the stars. But even Voyager, traveling at incredible speeds, would take over 70,000 years to reach the next star system. This is just the beginning. Beyond our solar system lies an infinite universe, filled with wonders we have yet to discover. The journey continues. Beyond our solar system, we venture into the vastness of interstellar space. The distance between stars is almost unimaginable. Our closest neighbor, Alpha Centauri, lies 4.3 light-years away. If Voyager 1 continued its journey at its current speed, it would take over 70,000 years to reach it. Between the stars, there is mostly emptiness, vast, cold, and silent. Yet, scattered throughout this void are rogue planets, drifting without a star, and cosmic dust left over from ancient supernovae. But let's zoom out further. Our entire solar system is just one of billions within the Milky Way galaxy, stretching 100,000 light-years across. The Milky Way is a massive, spiral structure teeming with stars, nebulae, and mysterious black holes. At its center lies a monster, Sagittarius A*, a supermassive black hole with a mass of 4 million suns. Its gravitational pull bends space and time itself. We are just one small part of this vast galaxy. Yet even the Milky Way is not alone. It belongs to a small group of galaxies known as the Local Group, including the Andromeda Galaxy, our closest spiral neighbor. And in 4 billion years, the Milky Way and Andromeda will collide in a spectacular dance of cosmic destruction and rebirth. Beyond the Local Group lies the Virgo supercluster, a massive collection of galaxies stretching over 100 million light-years. But even this is just a fragment of something even larger. The Laniakea supercluster, a vast structure containing over 100,000 galaxies, all slowly moving toward an unseen force known as the Great Attractor. As we move further and further out, the true scale of the universe comes into view. We are part of an ever-expanding cosmos, where each galaxy is a mere speck in a sea of trillions. But even as we look to the farthest edges, we must ask, what lies beyond? We have traveled beyond the Milky Way, past the vast superclusters of galaxies, and now we reach the very edge of what we can see, the observable universe. But what does that mean? What lies beyond? The observable universe stretches 93 billion light-years across. This limit exists because light from beyond that distance hasn't had time to reach us since the beginning of the universe. But the universe itself may be far, far larger, perhaps even infinite. At these unimaginable scales, galaxies form a massive cosmic web, threads of matter stretching across the void. Between them lie vast spaces of darkness, cosmic voids where almost nothing exists. This structure was shaped by the Big Bang, the event that started it all 13.8 billion years ago. Looking further back in time, we see the cosmic microwave background radiation, the oldest light in the universe, a remnant from when the cosmos was just 380,000 years old. This faint glow tells us about the origins of everything we know. And yet, beyond this cosmic horizon, we are left with only questions. Does the universe go on forever? Are there parallel universes beyond our reach? Could we ever travel beyond the limits of light and time? As we return to our own galaxy, we are reminded of something profound. In this vast and ancient cosmos, we occupy just a tiny speck in space and time. And yet here we are, able to look up and wonder. The universe is vast, mysterious, and beautiful. But perhaps its greatest mystery is that we are here, able to ask these questions. And maybe one day we will find the answers. As we continue our journey through the vastness of space, we leave the edge of the observable universe and venture into the unknown. What lies beyond? Could there be more galaxies, infinite in number, stretching endlessly? Or is the universe finite, curving in on itself like a cosmic sphere? Theories suggest we may be part of a vast multiverse, where infinite universes coexist, each with different physical laws, dimensions, or even versions of ourselves. These ideas, while speculative, are being explored through the strange physics of quantum mechanics and cosmic inflation. Looking back toward our own cosmic past, we see how everything we know, galaxies, stars, planets, emerged from a hot, dense state nearly 14 billion years ago. The expansion of space continues today, driven by a mysterious force known as dark energy, which causes the universe to grow at an accelerating rate. But what will be its fate? Some scientists propose that the universe will expand forever, growing colder and darker until all stars burn out. Others theorize the opposite, a big crunch, where gravity eventually pulls everything back together, restarting the cycle of creation. And then there's the Big Rip, where dark energy tears apart galaxies, stars, and even atoms themselves. In the grand scheme of things, we are witnessing only a brief moment in cosmic history. Our galaxy, our solar system, even our planet are temporary, small blips in the endless timeline of the universe. Yet, despite the vastness, we continue to explore, question, and search for answers. Perhaps one day, humanity will venture beyond the solar system, explore distant worlds, and uncover the secrets of the cosmos. But until then, we remain here, looking up at the night sky, wondering about our place in this infinite expanse. The more we learn, the more questions arise. And that perhaps is the beauty of the universe. It invites us to dream, to explore, and to never stop searching for what lies beyond. As we journey deeper into the universe's mysteries, we turn our attention to the building blocks of reality itself. What makes up the universe? And what unseen forces shape its destiny? Most of the cosmos remains hidden from us. Scientists estimate that only about 5% of the universe is made of ordinary matter, the kind that forms stars, planets, and even us. The remaining 95% is an enigma: dark matter and dark energy. Dark matter is invisible, yet its presence is undeniable. It acts like an unseen web, holding galaxies together with its gravitational pull. Without it, the Milky Way and other galaxies would spin apart. But what is it? Scientists believe it could be made of unknown particles that interact only through gravity. Despite decades of research, no one has directly detected dark matter, only its effects on the universe. Even more mysterious is dark energy, a force that seems to be pushing the universe apart at an accelerating rate. This strange phenomenon was discovered in the late 1990s, and it challenges everything we thought we knew about gravity and the fate of the cosmos. Will dark energy continue to dominate, leading to an empty, frozen universe? Or will it change over time, altering the course of cosmic history? To understand these mysteries, scientists have built powerful observatories like the James Webb Space Telescope and deep underground detectors searching for dark matter. But each discovery leads to more questions. Could our theories be incomplete? Could there be new forces of nature waiting to be uncovered? Quantum mechanics, the science of the very small, also plays a role in shaping the universe. At the subatomic level, particles behave in bizarre and unpredictable ways. Some scientists believe that quantum physics could hold the key to understanding dark matter, black holes, and even the nature of time itself. And then there is the ultimate question: what caused the Big Bang? Did time itself have a beginning, or has the universe existed forever in an endless cycle of expansion and collapse? Some theories suggest that our universe may have emerged from a previous one, in a grand cosmic rebirth that has been occurring for eternity. The more we explore, the more we realize how little we truly know. But this is what drives us forward, the endless search for knowledge. As we continue to push the boundaries of science, we move closer to understanding the greatest secrets of the universe. Perhaps one day, we will unlock the answers. But until then, the cosmos remains a vast, beautiful mystery, waiting for us to discover its truth. As we push further into the great unknown, we begin to explore the most powerful and enigmatic objects in the universe: black holes. These cosmic giants warp space and time in ways that challenge our understanding of physics. At the heart of most galaxies, including our own Milky Way, lies a supermassive black hole. Ours is called Sagittarius A*, a behemoth 4 million times the mass of the Sun. It is a region of space so dense that nothing, not even light, can escape its gravitational pull. But how do black holes form? And what mysteries do they hold? Black holes begin their lives as massive stars, burning through their fuel until they collapse under their own gravity. This collapse creates a singularity, an infinitely dense point where the known laws of physics break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. What happens inside remains one of the greatest mysteries in modern science. Some scientists believe that black holes could be portals to other regions of spacetime, perhaps even gateways to parallel universes. Others theorize that they may be the seeds of new universes, where the matter that falls in is reborn elsewhere in the cosmos. But without direct observation, we can only speculate. In recent years, we've made incredible advancements in studying these giants. In 2019, the Event Horizon Telescope captured the first ever image of a black hole, an achievement that brought us closer than ever to understanding these cosmic voids. With new telescopes and space missions on the horizon, we may soon uncover even more. But black holes are not the only extreme phenomena in space. Neutron stars, the remnants of dead stars, are among the densest objects in the universe. Just a single teaspoon of neutron star material would weigh billions of tons. These stars can spin rapidly, emitting powerful beams of radiation as pulsars, acting like cosmic lighthouses across the galaxy. Then there are magnetars, stars with magnetic fields trillions of times stronger than Earth's. These objects unleash bursts of energy so intense that they can disrupt satellites and even affect radio communications on Earth, despite being thousands of light years away. Beyond these stellar remnants, we encounter quasars, the brilliant hearts of active galaxies. These cosmic powerhouses shine with the energy of 1 trillion stars, fueled by supermassive black holes devouring surrounding material. Quasars illuminate the farthest reaches of the universe, acting as beacons from a time when galaxies were still forming. As we continue our exploration of these extreme cosmic events, we are reminded that the universe is a place of both order and chaos, of beauty and destruction. Each discovery reshapes our understanding of existence and brings us closer to answering the biggest questions. Where did we come from? And where are we going? The cosmos is a vast and evolving puzzle, and our search for answers is far from over. With each new discovery, we step closer to unlocking the secrets of reality itself. As we continue our journey into the unknown, we turn our attention to the grandest structures in the universe: galaxies, superclusters, and the vast cosmic web that connects them all. Galaxies are the building blocks of the cosmos, each containing billions or even trillions of stars, planets, and nebulae. Our home, the Milky Way, is just one of an estimated 2 trillion galaxies scattered across the observable universe. But galaxies do not exist in isolation. They form immense clusters and superclusters, bound together by gravity and woven into a vast cosmic web. The local group is our galactic neighborhood, a collection of more than 50 galaxies, including the Andromeda Galaxy, our closest spiral neighbor. Andromeda is on a collision course with the Milky Way, and in about 4.5 billion years, the two galaxies will merge in a spectacular cosmic dance, forming a new galaxy in the process. Beyond the local group lies the Virgo supercluster, a massive gathering of thousands of galaxies. But even this is just one part of something even larger: the Laniakea supercluster, an immense structure that stretches across 520 million light-years. All galaxies within Laniakea, including our own, are slowly drifting toward a mysterious region of space known as the Great Attractor, an unseen gravitational force pulling entire clusters of galaxies toward it. But what lies beyond? On the grandest scales, galaxies are not randomly scattered. They form a vast cosmic web, with filaments of galaxies stretching across the universe like threads of a giant cosmic tapestry. The spaces between these filaments are known as cosmic voids, regions so empty that they contain only a handful of galaxies in hundreds of millions of light-years. The existence of this cosmic web tells us something profound about the structure of the universe. These massive formations were shaped by dark matter and the early fluctuations in the universe following the Big Bang. Understanding how these structures formed and evolved helps scientists unlock the secrets of the early universe and predict how it may change in the future. Even more fascinating is the possibility that our universe is not alone. Could the cosmic web extend beyond what we can see? Some theories suggest that our universe may be part of a larger multiverse, where other universes exist with different physical laws, dimensions, and possibilities. We may never know for certain, but as we continue exploring, one thing remains clear: the universe is far more complex and interconnected than we ever imagined. Every new discovery brings more questions, and with each step forward, we move closer to understanding the fabric of reality itself. The more we explore, the more we realize how much remains unknown. But that is the beauty of discovery, the endless pursuit of knowledge, the quest to understand the cosmos, and the realization that every answer leads to new and even greater questions. As we journey further into the vastness of space, we turn our attention to the fundamental forces that shape the universe itself. From the smallest subatomic particles to the grandest cosmic structures, these forces govern everything we see and experience. The universe is held together by 4 fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Gravity, the weakest of these forces, is also the most far-reaching. It is the invisible hand that keeps planets in orbit, binds galaxies together, and sculpts the large-scale structure of the cosmos. Yet, gravity remains one of the biggest mysteries in physics. Scientists have long sought a way to merge gravity with quantum mechanics to create a unified theory of everything. Electromagnetism is the force responsible for light, electricity, and magnetism. It governs how atoms and molecules interact, making life itself possible. From the energy of stars to the signals in our electronic devices, electromagnetism is one of the most well-understood forces in nature. The strong nuclear force holds the atomic nucleus together, binding protons and neutrons. It is the most powerful of the 4 forces, responsible for the energy released in nuclear reactions, including the fusion processes that power the sun. The weak nuclear force is responsible for radioactive decay and plays a crucial role in nuclear reactions within stars. It is fundamental to the processes that create the elements necessary for life. But beyond these known forces, physicists speculate that there may be others yet to be discovered. Could there be a fifth force of nature? Some experiments suggest that unknown forces might be at play in the universe, altering the way galaxies move and influencing cosmic expansion. We also explore the possibility of extra dimensions beyond the familiar three of space and one of time. Theoretical models, such as string theory, suggest that additional dimensions could exist, hidden from our perception, but shaping the universe in ways we do not yet understand. As our knowledge expands, we push closer to answering the deepest questions. What is reality made of? Are the forces we observe truly fundamental? Or is there a deeper layer of reality waiting to be uncovered? The search for these answers continues. With new telescopes, particle accelerators, and deep space observations, humanity is on the brink of unlocking the next great mysteries of the cosmos. Each discovery reshapes our understanding of the universe and brings us one step closer to unveiling its ultimate nature. As we stand at the frontier of knowledge, we are reminded that the universe is not just a collection of stars and galaxies. It is a grand and intricate dance of forces, energy, and space-time. And in this vast and mysterious expanse, our quest for understanding is only just beginning. As we near the final stretch of our journey through the cosmos, we turn to one of the greatest questions of all. Are we alone in the universe? Could life exist beyond Earth, scattered among the stars and distant galaxies? For decades, scientists have searched for extraterrestrial life, studying planets, moons, and deep space signals in the hopes of finding evidence of living organisms beyond our world. Our search begins with exoplanets, planets orbiting stars beyond our solar system. Thousands have been discovered, some in the habitable zone, where conditions may support liquid water and potentially life. One of the most promising candidates is Proxima b, an Earth-sized planet orbiting the nearest star to our solar system, Proxima Centauri. Could it harbor alien life? What about the moons of Jupiter and Saturn, Europa and Enceladus, where vast oceans of liquid water exist beneath icy crusts? These celestial bodies may be among the best places in our solar system to search for life. Scientists have also turned their attention to biosignatures, chemical signs of life that could be detected in the atmospheres of distant exoplanets. Using telescopes like the James Webb Space Telescope, researchers hope to analyze these atmospheres for oxygen, methane, and other elements that might suggest the presence of living organisms. But what if intelligent civilizations exist? The search for extraterrestrial intelligence, SETI, has scanned the skies for decades, listening for radio signals from deep space. Could an advanced civilization be trying to communicate with us? And if they're out there, why haven't we heard from them? This mystery is known as the Fermi paradox. If the universe is teeming with habitable planets, why haven't we found definitive proof of intelligent life? Some theories suggest civilizations may be too far apart, too short-lived, or even deliberately avoiding contact. Others propose the existence of the Great Filter, an unknown barrier that prevents civilizations from advancing beyond a certain point. As our technology improves, so do our chances of answering these questions. Missions to Mars are searching for ancient microbial life, and future telescopes will give us an even clearer view of exoplanets. We are closer than ever to discovering whether we are truly alone or just one of many civilizations scattered across the cosmos. The search for life beyond Earth is one of the most profound scientific endeavors of our time. With every new discovery, we move one step closer to answering the question, are we alone in the universe? Or are we simply waiting for the right moment to make contact? As we reach the final chapter of our cosmic journey, we reflect on what we have discovered and what still remains a mystery. The universe is vast beyond imagination, stretching across distances so immense that they challenge our very understanding of reality. Yet, within this grand expanse, we have seen the forces that shape galaxies, the strange objects that defy logic, and the profound questions that remain unanswered. Our journey began with Earth, our tiny blue home, before expanding outward past the moon, the planets, and the distant reaches of our solar system. We ventured into the Milky Way, explored the great cosmic web of galaxies, and reached the very edge of the observable universe. Along the way, we have uncovered the secrets of black holes, dark matter, dark energy, and the fundamental forces that govern reality itself. And yet, the more we discover, the more questions arise. What lies beyond the limits of what we can see? Is the universe truly infinite, or does it have an edge? Are we alone, or is life scattered among the stars, waiting to be found? These questions drive humanity forward, pushing the boundaries of science, technology, and exploration. The future of our journey lies in the hands of those who dare to look beyond the familiar and into the unknown. Telescopes like the James Webb Space Telescope are peering deeper into time and space than ever before. Future space missions may take humans to Mars, and perhaps one day beyond our solar system. Advances in physics may reveal the true nature of dark matter and dark energy. And who knows? Perhaps the greatest discovery of all is yet to come. The universe is not just a place of stars and planets. It is a story of creation, of destruction, of endless cycles and cosmic wonders. And in this vast, mysterious expanse, we find ourselves a part of it all. We are not separate from the universe. We are made of the same elements as the stars. We are the universe, looking back at itself, seeking to understand its own existence. As we conclude this journey, remember that exploration never truly ends. Every new discovery is a step towards something greater, a key to unlocking the next great mystery. The cosmos calls to us, inviting us to keep searching, to keep wondering, and to never stop asking the biggest questions of all. This is our place in the universe, small, yet significant, a brief flicker in time, but with the power to uncover the greatest secrets of the cosmos. And so, our journey continues,